In this lesson, we shall be looking into linear inequalities. In our previous video, we covered the concept of linear equations, whereby we learned how to tackle problems involving linear equations, as well as linear equations that involve fractions. Do well to check out my videos on linear equations and linear equations involving fractions to get yourself armed with the basic knowledge. In this video, we shall be covering the concept of linear inequalities. So let's get started with the basics. What is linear inequality? Linear inequality is simply any mathematical statement that compares two expressions. We discussed about expressions in our previous video. We said an expression is simply a mathematical statement that involves numbers or letters, as the case may be. Now, still on the concept of algebra, we brought up the concept called linear inequalities. One thing each and every one of us need to take home with when it comes to linear inequality is that it compares two expressions. Expressions could be a monomial such as 2x, 3y, 4z, a or b, etc. Or it could be a binomial such as x plus 1, x minus y, 2x plus z, etc. Or a trinomial, which could be x squared plus 2x plus 4, or 2x squared minus 3y plus 4. Any expression, it could be a polynomial as the case may be. Now, any time these two expressions are being compared with the help of a greater than sign or a less than sign or a greater than and an equal to sign or a less than or equal to sign, then we call that a linear inequality. Example, if I have two binomials such as x plus 2 and x minus 3 being compared not with a equality sign. If it is compared with equality sign, then we call this a linear equation, and we know how to go about that. But this time around, we are looking at linear inequalities when these mathematical expressions are compared not with equality sign, but rather the equality sign is replaced with either a greater than sign or a less than symbol or a greater than or equal to symbol or a less than or equal to symbol. Anytime you come across this sign, then you know that the equation you're looking at is an inequality. So in this video, we shall be covering the whole concept involving inequalities. So let's begin with the first concept on inequalities, which is what? Number line. Number line. Now, what is a number line? A number line is simply a line that shows range of values. Notice that if I say x is greater than 3, what does it mean? It simply means that x is a range of value. A range of value beginning from what? 3 and above, beginning from 4 and above. Since we say it is greater than 3, it means that 3 is not included. So we have something from 4 and above. That is what x is. So anytime you come across inequalities, the solutions are always range of values. So if we say x is less than 4, it means that x is less than 4. That is from 3 down. That is what x is. And it is important to understand how to represent some of these things on a number line so that you understand the graphical information that the inequality is trying to send. So how do we represent inequalities on a number line? So what is a number line? Let's give an example. It's simply a line that shows range of value. Let's say we have a line whereby we just shows numbers. Numbers ranges from minus infinity through 0 all the way to positive infinity. So it's simply moved from minus infinity all the way down to, let's say, minus 2, minus 1, 0, 1, 2, till infinity. So this is what we call a number line, a range of numbers starting from negative infinity to positive what? Infinity. So how do we represent inequalities on a number line? Like we said, inequalities includes greater than, less than, greater than or equal to, and less than or equal to. Now, anytime you are representing numbers involving greater than or less than, you use a small circle that is not shaded to represent that. And then anytime you are representing a greater than or equal to, or a less than or equal to, you use a small circle that is shaded to represent that. So let's say we want to represent a number on a number line. Let's say we want to represent the fact that x is greater than 3. How do we represent that? Notice that x greater than 3 means that 3 is not included. So to represent this on a number line, we simply do what? Draw our line and then put our 0 with our minus infinity all the way down to minus 1, minus 2, then 1, 2, we just get to 3. Now this is 3. So we simply draw a line there. This is 3. And then we use our circle that is not shaded. Since we are dealing with greater than, not greater than or equal to. And then we say if x is greater than 3, means that the value of x is from this point and above. So x could be 4, x could be 5, x could be 6, anything all the way to what? Infinity. That is what x is. This is how to represent number on a number line. So let's take another example. Represent x is less than 4 on the number line. How do you do that? Simply go to our number line and identify where 4 is. So this is 4. We drop it. Draw a circle that is not shaded. And then where will the arrow go? Upward or downward? Notice that x is less than 4. So it's going to go downward. Less than 4. So this is it. And that is the answer. So feel free to pause the video and represent this on the number line. X is greater than minus 1. How do you represent that on the number line? So you simply draw your number line and put your 0. Minus 1 should be around here. So this is minus 2 all the way to negative infinity. And then this is 1, 2 all the way to positive infinity. So you just quickly drop. Where is not minus 1? This is not minus 1. So you take it and put your circle that is not shaded. You now ask yourself, where is the direction pointing? Say x is greater than minus 1, meaning it's pointing to the left. It's greater than. This is greater than, and this is less than. So where we have greater than minus 1, you push the arrow there. And that is the answer. So feel free to pause the video and tell me what we have here. Now, what if you have something like this? X is greater than or equal to 3. How do you represent that on a number line? So to represent this on a number line, you simply draw your line and drop the 0 point mark. This is minus 1, minus 2, all the way to negative infinity. Since you are dealing with 3, just identify 1, 2, 3. Then this is 3. Just put it. Now, because it is greater than an equality sign, so you go ahead and represent that with a shaded circle. And then, because it is greater than or equal to 3, then it should point from 3 all the way to what? Infinity. That's from 3, that means that 3 is included. 3, 4, 5, 6. This shaded point here means that 3 is included. And that is why we represent that in that form. So feel free to pause the video and represent this on a number line. What if we have x is less than or equal to 2? How do you represent that on a number line? Simply draw your number line and add your 0. This is 1, 2 should be around here. Just put it, because of less than or equal to, you shared it, means 2 is included. And then it is less than, meaning all the way down here. So you can make up the part 2 all the way to minus infinity. This is 3 all the way to positive 1, infinity. So that is how to represent inequalities on a number line. Okay, that's it about number line. One thing you must understand is that the number line is simply a graphical way of representing a given linear inequality. So anytime you come across a linear inequality, problem, whenever you get the value of x, you remember that your value, your variable, the value, the answer is always a range of value. So to represent that, you've seen how we represent a given problem involving a linear inequality on a number line. So let's get started with some basic problems so that to get ourselves familiar with linear inequality and how to go about it. Now, to solve a linear inequality problem, the same approach that you implement while solving linear equation is how to go about it. Except that when dividing a given linear inequality, let's say after solving a problem on linear inequality, you arrive at a point where you have minus x is less than 2. And this is not the value of x. You want to eliminate this negative. So anytime you are dividing all through with negative, this minus x means minus 1 multiplied by x. And you have this divided by, it's less than 2. And you want to eliminate minus 1. You divide all through by minus 1, divide all through by minus 1. And when that happens, you have that x is greater than minus 2. So what do I mean by this? What this implies is that anytime you are dividing with negative, the greater than sign changes to its opposite one, which is going to be, sorry, the less than sign, the less than symbol changes to what? Greater than symbol. So you must take note of that when dealing with what? Linear inequalities. So after solving a given problem, you arrive at a point where you divide by negative or negative of any number. Whenever you divide a given linear inequality problem with negative, if it is a greater than sign that was there, it will change to a less than symbol. If it is a less than symbol that was there, it will change to a greater than symbol. The same thing happens when you have a greater than or equal to symbol. It is going to change to what? A less than or equal to symbol once you divide with what? Negatives. And that's one important information you need to take note of. If you divide with a positive number, you don't have a problem. Your symbol remains the same. But once a negative symbol is involved, negative number is involved, then the symbol is bound to what? Change. So having armed ourselves with this basic knowledge, so let's take down some real problems and tackle linear inequality. So let's take this example. Let's say we have 3x plus 13 is less than 1. Question says find x. How do we find this? Just anytime you're given a given linear inequality problem, the first thing you need to do is what? Treat that linear inequality problem as a linear equation. Linear equation in the sense that just solve the problem as though this particular symbol here is just an equality sign, and you just solve it like that, bringing out the symbol, and then at the end of the day, that's whatever thing you got there is going to be your answer. That is how we solve problems involving linear inequality. So feel free to check up on my video on linear equations to understand how this problem is solved. So let's quickly solve this problem. We say that 3x plus 13 is greater than 1. So to solve this problem, what do? First of all, we need to collect the like terms. Notice that there's 1 here, this is a constant, and there's another constant here, and there's an x variable here. So we need to make x one side and the constant one side. So we need to take off minus plus 13 that is here. So to eliminate plus 13 and add it to this point, we do what? We take the inverse operation, which is this plus 13. Then we're going to take what? Minus 13, and then add it here, minus what? 13. Then we evaluate. So in evaluation, 3x comes down, and then the whole of this becomes equal to 0. Then I will have what? My greater than sign, and then I have 1 minus what? 13, and that is it. So what do we have next? We have that 3x is greater than what? 1 minus 13, and that is what? Minus 12. So to find x, what do? We divide all through by what? 3. Notice that what I'm dividing now is a positive number, so nothing will happen to the greater than sign. So I will divide by 3 here, divide by 3 there. So 3 take care of 3, I'm left with x. So I can divide 3 into 12. 3 going to 12, you have what? 4. Because of this minus, it becomes minus 4. So my final answer is going to be what? X greater than minus 4. And that is the answer. Next, we represent our given answer on a number line. Notice that our final answer is x is greater than what? Minus 4. So to represent this on a number line, we simply what? Draw our line and then put our 0 there. This is minus infinity, negative infinity, then all the way to minus 2 dot dot, minus 1, as the case may be, 0, 1, 2, and 3. So we simply locate minus 4. Minus 4 should be around here. Here we have, should be around minus 4, minus 3. This is negative infinity. So minus 4 should be around here. So we take it up. Remember, this is greater than sign. We're going to take a small circle with that is not shaded. So we say x is greater than minus 4. So which direction will it point? Rightward or backward? Definitely is going to be rightward. And this is the representation of this problem on a number line, and that is the answer. So let's take another example. So let's say we have 6x minus 2 less than 2x plus 8. The problem says find the value of x and represent your answer on a number line. To solve this problem, we just go ahead and treat this inequality sign as an equality sign. So we just go ahead and solve that problem. So the first thing we need to do is to collect the like terms. To collect these like terms, we simply do what? Eliminate this 2x that is here and bring it over here. So we eliminate this minus 2 that is here and take it over there. So we take the minus 2 to the other side and take the 2x to this side. To do that, we simply do what? Introduce the opposite operation that is there. So this is plus 2, so I will introduce minus 2x here, and introduce minus 2x here. Then this is minus 2, I will introduce plus 2 here, plus 2 there, and then we go ahead and simplify. So to simplify, we have this, we measure up to what? 0. This, we measure up to what? 0. So we have 6x minus 2x is less than 8 plus 2. So to simplify, we have 6x minus 2x will give us what? 4x, and 4x is less than what? 8 plus 2, which is what? 10. So to find x, we divide all through by 4, and we have it that 10 divided by 4 is going to give you, is going to be what? X being less than what? 5 over 2, and that simply means that x is less than one whole number 1 over 2, because 5 over 2 means one whole number 1 over 2, and that is the answer. So next, we represent that answer on a number line. So to represent this given answer on a number line, what we do is we just simply draw the line and identify where one whole number 1 over 2 is. That's 1 and half. To represent 1 and half, we simply is going to be between 0 and 1. Between 0 and 1. That's why we have 1 and half. So this is what? Minus 1, minus 2, all the way to negative infinity, and all the way 1, 2, 3, all the way to positive infinity. So 1 and half is going to be around here. So we represent that here. Just put it here. Between here, we just write 1 whole number 1 over 2 here. Sorry, between 1 and 2, as the case may be. So this is 1. So 1 whole number 1 over 2 should be around here. So this is where is it. Now, remember, this is less than symbol. So we've introduced a circle that is not shaded. So this becomes less than sign. It's going down because this is less than 1 whole number 1 over 2. And that is the answer. So feel free to pause the video and try this problem out yourself. Let's say you have a given problem like this. Let's say you have 3x minus 6 is less than 2 into x plus 4. Feel free to pause the video and try this problem out yourself. So to solve this problem, we simply do what? Eliminate the bracket. Eliminate what is in the bracket. To eliminate what is in the bracket, we simply do what? We simply multiply the constant with every single term in the bracket. So let's start with this. So this becomes 3x minus 6 less than 2 times x will give us 2x plus 2 times 4 is what? 8. So next we collect the like terms. This is what? 2x, I'll eliminate it and bring it over here. So to do that, we introduce minus 2x minus 2x, and then minus 6, we take it to the other side. So this will become plus 6 plus 6. So this will eliminate these two. So this is equal to what? 0. And this is equal to what? 0. And then I'm left with what? I'm left with 3x minus 2x less than 8 plus 6. So go ahead and simplify. 3x minus 2 is simply what? X less than 8 plus 6 is simply what? 14, and that is the answer. So next, we represent this on a number line. So to represent this on a number line, as usual, we simply draw our number line and identify 14. 14 should be around here, and this is 0, 1, all the way to 13. So 14 should be around here, and this is all the way to infinity. This is negative infinity. This is minus 2, or the minus 1, and all the rest of them. So where are we looking? Our target is of 14, so this is 14, and it is less than, so we simply use a 0 without that is not shaded. So this goes down, and that is the answer. Now notice that on this number line of a 10 does not require scaling. You don't need to scale it to know what the number line is going to be. You can decide to write out the numbers in full, such as I will write out the numbers as 1, 2, 3, 4, all the way to I get to 14, and then draw the arrow down. So it is not to be drawn to scale. Just sketch it and show them how this particular thing relates on the number line, and that's it. You got the answer. So now let's try out some problems involving fractions. So do well to check out my video on linear equations involving fractions to understand how to tackle problems like that. So let's take an example. Let's say we have x over 2 minus x over 6 being greater than or equal to 4 over 9. How do we tackle this problem? The first step in dealing with fraction is to take the denominators and find their LCM. So let's take the denominator and find their LCM. We take 2, 6, and 9. We find the LCM. The LCM, let's say 2 go here, you have 1. 2 into 6 is what? 3. 2 into 9 cannot go, you bring it down, it's 9. What can go? 3. 3 go into this is 1. 3 into 3 is what? 1. 3 into 9 will give us 3. 3 can go again. 3 here, 1, 1, 1. So the LCM is 2 multiplied by 3 multiplied by 3. And what is that? This is 2 times 3 is what? 6. 6 times 3 is what? 18. So that is the LCM. So we've gotten our LCM, which is what? 18. So the LCM is equal to what? 18. So the next step is to take each of the fraction and multiply them by the LCM. So we take the first fraction, x over 2, multiplied by the LCM over 1, minus x over 6 multiplied by the LCM over 1 is greater than or equal to 4 over 9 multiplied by the LCM over 1. So we go ahead and simplify. To simplify this, we have 2 can go into 18. How many times? 9 times. So you now have 2 here, 1, 2 into 18, 9. 9 times x will give what? 9x minus 6 here is 1. 6 go into 18, you're simply going to have what? 3. So you have 3 times x. You have 3x. And this is greater than or equal to 9 here is 1. 9 into 18, you have what? 2. 2 times 4 is what? 8. And that's what you have. So the next step is to do what? Is to simplify further. So let's go ahead and simplify. So we have 9x minus 3x. What do you have? 9 minus 3 is going to give you what? 6x. 6x is greater than or equal to what? 8. So what's the next? We need to just divide all through by the coefficient of x, which is what? 6. Divide by 6, divide by 6. 6 here, you have what? X. X will be what? Greater than or equal to what can divide? 2 can go into 8 here, you have what? 2 go into 8, you have 4. 2 go into this, you have what? 3. So our answer will be 4 over 3. And that is the answer, which can also be written as x greater than 4 over 3 will give you what? 1 whole number, 1 over 3. And that is the answer. So next, we represent this on a number line. So to represent this on a number line, we simply draw a line and then find 1 whole number 1 over 3. 1 whole number 1 over 3 should be between 1 and 2. So this is 0. So this is 1. Between 1 and 2, I will have 1 whole number 1 over 3. Then before getting to 2, then 3 all the way to what? Positive infinity. This is minus 1, minus 2, all the way to negative what? Infinity. So from here, I put it there. Now remember, notice that this is a greater than or equality sign. So it's going to be shaded. So this is what? X greater than this. So it means 1 whole number 1 over 3 is included. And the arrow goes to the right. And that is the answer. So feel free to pause the video and try this problem out yourself. Let's say you have x over 5 minus 2x minus 1 over 5, and this is less than or equal to 12. How do you tackle this problem? To tackle this problem, you simply make this one over 1. So the next you do what? Find the LCM of the denominator. Notice that this is 5, this is 5. If I have to find the LCM of the denominator, since the denominator has the same value, 5, 5, 5 can still divide. So their LCM is simply what? 5. LCM is simply 5. You can verify that out. So what we do, we take each of the fraction and multiply by the LCM. So we take x over 5, we multiply by the LCM, 5 over 1, minus, we take the next number, 2x minus 1, divided by 5, we multiply by the LCM, 5 over 1. And this is less than or equal to what? 12 over 1 multiplied by 5 over 1. So what next do we do? We simply simplify it. So this is 5 here 1, 5 here 1. So I'm left with 1 times x, which is what? X, minus 5 into this 1, 5 here 1. So 1 times 2x minus 1 will simply give you what? 2x minus 1. So what's the next thing? This is less than or equal to 12 times 5 will give you what? 60. So the next stage is to do what? Next is to remove the bracket. So to remove the bracket, we have x. Notice that this negative will multiply everything inside this bracket. So we have minus 2x. Minus times minus will give you a plus 1. And this is less than or equal to what? 60. So what do we do next? We simply do what? Expand. So we have x minus 2x will give us what? Minus x plus what? 1 is less than or equal to what? 60. Notice that we need to what? Collect the like terms. In collecting the like terms, we need to collect all x's one side and all constant on the other side. So we need to eliminate plus 1. To eliminate plus 1 here, we add negative 1 and negative 1 there. So what do we have? We have it that this is what? This becomes 0. And what we have left is minus x less than or equal to what? 60 minus 1. And this has it that minus x is less than or equal. 60 minus 1 will give you what? 59. So the next is to find what x is. So to find x, I need to divide all through by minus 1. So I have minus x. Notice that minus x is the same thing as minus 1 multiplied by x less than or equal to 59. So we divide all through by minus 1, minus 1. Remember what I told you, anytime you are dividing with negative, then this inequality sign will be what? Affected. So it will simply what? Turn to the opposite direction. Since I'm dividing this with negative, so this, take care of this, I'll have x. X will be what? Greater than or equal to what? Minus 59. And that is the answer. So to represent this on a number line, you simply what? Draw your line and then locate minus 59. Minus 59 should be around here. You have your 0, and this is all the way to minus 1, and this is minus negative infinity. This is 1, 2, all the way to positive infinity. So to represent this on the number line, you simply what? Drop it. Remember, this is greater than or equality sign, so it's going to be shaded, and then it's shaded to the what? To the right. And that is how to tackle that problem. That is the final answer. So let's take another example to solidify our understanding of linear inequality. So let's say we have 3x over 4 minus 2x over 3 is less than or equal to 5x plus 4 over 12. Feel free to pause the video and try this problem out yourself. To solve this problem, as usual, we simply find the LCM of the denominator. So we find the LCM. Notice that the LCM of 4, 3, 12 is going to be what? 2 can go here. 2 into this, you have 2. 2 into this cannot go, you bring down 3. 2 into 12 is 6. 2 can go here, you have 2 into this is 1. 2 cannot go into 3, you bring it down. 2 into 6 is simply 3. What can go? 3. 3 here, 1, 1, 1. So the LCM is 2 times 2 times 3, and that is what? 2 times 2 is 4. 4 times 3 is what? 12. So we've gotten the LCM to be what? 12. So we write it down. LCM is simply 12. So we take each of the fractions and multiply by the LCM. So we have 3x over 4 multiplied by 12 over 1 minus 2x over 3 multiplied by 12 over 1 is less than or equal to 5x plus 4 divided by 12 multiplied by 12 over 1. So how do we tackle this? So we'll go ahead and simplify. So to simplify this, we have that 4 can take care of 1. 4 here, you have 3. 3 here, 1. 3 into 12, you have 4. 12 here, 1. 12 here, you have 1. So what we are left with is 3x times 3. And that is what? 3 times 3 gives what? 9x minus 4 times 2 is what? 8x. Is less than or equal to what? 5x plus 4 multiplied by 1, which is the same thing as 5x plus 4. So to go ahead and simplify, so we simplify further by saying 9x minus 8x, we have what? We have 9 minus 8 is simply what? X, being less than or equal to 5x plus 4. So notice that we have 5x here and x here, so we need to bring x to this side. So to bring x here, we simply subtract x from here, 5x from here, subtract 5x from here. So we evaluate this will amount to 0. So I'm left with what? X minus 5x is less than or equal to what? 4. So what's the next thing we do? We simply have it that x minus 4x. So 5x is the same thing as x added 5 times. So when you remove x and that is added 5 times, one of the x's, you have what? Minus 4x. And this is less than or equal to what? 4. So what do we do next? We divide all through by negative 4. Divide all through by negative 4. Notice that once we divide by negative, this inequality sign will definitely be affected. So once we are dividing by negative sign, so we have it that x becomes equal to 4 can take care of 4, you have what? 1. So what I've left with is x being, instead of less than or equal to, it will now become greater than or equal to minus 1. Because 4 here is 1, 4 here is 1. So you're left with minus 1. And that is the answer. So having gotten this, the next stage is to plot it on a number line. So we draw our number line. We say that x is greater than or equal to minus 1. So it simply means find minus 1, which is around here. We simply put our small circle, and this is greater than or equal to, so we're going to shade it. Means minus 1 is included. So greater than is pointing this way. So, and that is it. So we can fill up the rest, which is 1, 2, all the way to positive infinity. This minus 2, all the way to negative infinity. And that is the answer. So that is how to tackle problems involving linear inequality. So that's going to do for this video. I will see you guys in the next video.